Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about Titan submergible tragedy. So let's dive deep into it. So what is this idea of submergible, not submarine? Well, reality is basically a miniature submarine with less power. Basically, it cannot rely on itself for long duration, where you can have a submarine that is, if it's a submarine, it should be able to handle itself for, let's say, 1 or few days at least, or if it's a military system, easily should be able to stay underwater for months on end. So these puppies are like very sprinter kind of thing, basically hours or maybe 1 day or 2 day. Like that's the whole point. The stamina is very seriously limited and they always require a support vessel. Like a submarine, military submarine, that's a submarine. That's like, I got this. Like a support vessel is not necessary. Here, support vessels are mandatory. They cannot function without them. So that's how you separate these two things. Meaning a military submarine, it can literally come from port, go to where it needs to go. Where these puppy have to be carried there, where like the dive site location, and then they will be dropped there. And most of them are made for order. For example, military submarine, they have a sort of fixed design. Basically, they are a long capsule based length and diameter changes, but inherently it's just a fancy capsule with super high tolerance. So that's the design. That's a roughly thing. And generally, military submarines are built in orders. So like you're gonna have 10 of these, 20 of these, whatever have you. Here, it's like every model you see, it's a custom built one. Every single one. Like there rarely is, unless some rare thing happen, best you're gonna see is two, because generally it's preferred to build two of them, because if you have one for a rescue reason, you may want to build another. If you're building one more is not that expensive, especially if you want to have that second one just as a remotely operated vehicle to do search and rescue and all that. Sometimes that is done, but most of the time every model is a unique one, and that's why it requires very stringent certification. So they are custom made for order for research and development, biological studies and all that jazz, and oil and gas industry, they also love it. Nowadays for undersea, fiber and all that, they require a lot of attention from these. Now, they always, generally most of the time, as a rule of thumb, they go much deeper than military submarine. I'll explain that why exactly that is, but military submarine do not go to the depth of these puppy. For example, this and this one, this is a limiting factor, and this puppy is James Cameron's puppy. Both of them can reach to Mariana Trench. Basically, they are built in such a way that they are the final spot, meaning how strong you have to build it, exactly like these. They actually reach to the final point where we do not have any other location on earth that goes deeper than that. So flat out, these are the like pinnacle, you would say. Like here's this is the part that actually matters, and all this is support equipment. This ball is that only matters. All of that structure is just auxiliary equipments. So they do in terms of basically volume, in terms of range, they are very small. They are like in this puppy, that's how James Cameron was sitting. Not even joking, like it's a very cramped space, even in this. So that's the world of submergible. Now the core difference is submergible is generally plays love with crushing depth. Now crushing depth, simple fact in this is like depth, the deeper you go, it gets brutal, and it gets brutal very fast. For example, you can start at 100 meter. It's still bad. It's like 10 bar of pressure. 1 bar is generally 1 atmosphere. So you're inside and you're outside, they are having a fight, and the fight is of basically 9 bar. So if you have a chamber, you have basically 9 bar trying to get in. That's bad. If you go to 1000 meter, that is 100 bar. Now you have 99 bar trying to get in. That is very brutal. Now, why it is that brutal? Well, water is uncompressible. For example, if you are in a scenario where, let's say, you are going into some, let's say, gas giant's atmosphere, and you can have the same thing, 1 atmosphere inside and 100 atmosphere outside, the pressure that is exerted on you would be more or less the same. But water is extra brutal because it's uncompressible. It will crush you. While the atmosphere, it may compress, it may change. So that creates a very serious issue. Now that issue is with void, meaning if, let's say, this is an Indian submersible that if I'm not mistaken goes to 6000 meter. If you open the hatch and you try to swim out, there won't be you anymore, meaning there won't be bones, there won't be teeth. There, at best case scenario, maybe some Rolex and some Submarinos, at best some watches, but 100% of the time there won't be any biological material left of you. It's like poof. Why? Our biological material is made out of cell. Cell has a cell wall and a liquid and a nucleus. Now here's the deal. The liquid is under 1 bar of pressure. It's designed for that atmosphere. Now it can handle some atmosphere, like 2 bars, few bars. You can go into deep seas, diving and all that. Some bar it can handle. 100 bar is like no, it will go poof. Basically, you will go from biology to poof. Nothing would be there. Like no bones, no teeth, nothing. Void. Especially even if you go like light depth, lungs becomes an issue. Water really do not like voids. So whenever we build things around it, like electronics and all that jazz, they are always submerged in oil. Like the first vessel that actually went to that depth, they had a giant oil tank on top of it, petrol tank basically. Not even joking, it actually had petrol in it. That was the easiest way they could figure it out for low cost to have very high buoyancy, which they needed. So water is uncompressible, it hates void space, so it will annihilate it. So if look from military's point of view, if military fires a torpedo, and the torpedo battle is designed from submarine to submarine warfare, of course it can attack the top, but that's the easy part. Like you are below, you fire something up, that's easy. But the worst thing would be, let's say you are at 800 meters, somebody has 1800 meters, they fire a torpedo, it will not go to 1800 meters. Flat out, it will self boom itself at 1.5. Because torpedo has to have things, right? It has to have sensor. Everything has to be void free. You can make majority of things void free, but not everything. And be mindful, all explosives have a compressional limit. Meaning if you keep compressing the explosive, at some point it will self detonate. Like it will just like, no, I'm out. So, and be mindful, 1.5, I'm exaggerating a lot because most military submarines, they never specify what exact depth that it can go. But 800 meters to 900 meters is the, basically you have to be serious about this. And they say like 800 meters is like well known, and some Russian nuclear submarines claim to go even deeper than that. Can they go deeper? Yeah, to some extent. But can they do twice as that? Hell no. How do we know? Every time these submarines are decommissioned, most of the things become obvious, and the hull thickness is one of those things that you know, and you can do some mathematics. And water is kind of super easy to calculate in computer, and you're like, nah, you cannot take this design and drop it to like, let's say 2 kilometers deep. At that point, that would be scary. Imagine it this way, like there is American submarine and there's like one submarine that is 1 kilometer below them. There are places in ocean that has that kind of verticality, but it would be scary for, like, they can't do anything. But if they have the technology to build something that withstand, let's say 2 kilometer, and they can build a torpedo, they can just like, hey, American man. They don't even need stealth at that point. No depth charges will go that deep and do anything. It's like, hey, like water is the shield there. It's like, hey, and they can hit on top. So that's why torpedoes are. And even when you see ICBMs, they are also designed to be very, again, they are rockets, so they are very weight limited. You cannot make them ultra strong armor so they can launch from, let's say, 100-meter deeps. That's why these things are generally almost surface launched. So you must have seen any, if you have seen any basically army movie where they're talking about submarines, they always talk about like satellites can detect your submarine opening is Bombay doors. That's what they're talking about. Like if the torpedo doors are open, or like ICBM doors are open, its surface submarine has to come almost to the surface. Almost. Now, how close? Of course, nobody will specify, but it's very close. I don't even think it's like few meters deep. Because you can see it in satellite pictures. It's that close. Like that's how clear it is. Oh, you have this many doors. 2 doors are open or all doors are open, you can see it. So it has to be, so this can be done. And this is a common example you can see, like where you have tanker cars. Many times people have poofed it accidentally, where they use basically high pressure, high temperature steam to clean it, but you're supposed to never seal it. You're supposed to put it, steam like cleans everything and evacuates everything is awesome. But here's the, it evacuated the air. If you seal it now, the steam eventually will cool down. Once it cools down, the atmosphere outside is like, bro, I'm 1 bar. The atmosphere inside is like, bro, I'm less than 1 bar. That's a 1 bar differential. When you're talking about something, these things could be handling around 600 to 1 ratio. That's why it's extremely brutal. So that is what we are talking about when we are talking about crushing that. It's not an easy thing to do. Every square inch of your surface has to be inspected. Any failure, any deviation equals poof. It's not like, oh, no, it's poof, done. So that's the crushing depth. So what about OceanGate? Now, OceanGate is an American privately owned company. It started for tourism, industry, and research and development plus exploration. So these were their umbrella that they were taking care of. 2009, so not a very old company, 14 years ago. 47 employees, not a very large company also. And they started with this puppy, Antipodits, this puppy, and it was 300-meter class, quite deep. And then we had Cyclops that was 500-meter deep. That was Cyclops 1. And then they directly jumped to Titan, which was Cyclops 2. They all renamed it. That puppy was made in 2018, and that was like 4,500 meters. They made a huge jump from 1 to 2, like exponentially larger jump. It's like almost like some company that is only building a single seater to directly jumping to Airbus A380. You'll be like, bro, please build something in between. Please, come on. Don't jump there. Like, build something in between. Maybe like let's say single seater to let's say 50 seater, then you jump to that. You do not directly go from I built a single seater plane, that's awesome, I'm gonna directly build Airbus A380. Yeah, no. So they did literally equivalent of that. Now what exactly is the problem? Now problem is going from 0.5 kilometers to 4.5 kilometers. Yeah, that's bad. That's not as easy as you may think. Like water I specified, like the tolerance on your sphere, basically geometry should be perfect. You cannot even get 0.5% of up and down. So if you're designing something that is let's say 10 meter in diameter, it has to be precise. Like 1 centimeter up and down won't be allowed, because I specified you have less than 1% tolerance, and 1% is very generous. The deeper the depth, the less tolerance you're gonna get. Meaning if it's a sphere, it has to be perfect. If it's a cylinder, it has to be a perfect cylinder. So that's why. And they ignored everything. They ignored established convention. For example, I specified there are 2 submarines that submergible that went to Mariana Trench. These 2 puppy. Now what are the same thing about them? Main capsule is a sphere. Main capsule is a sphere. Benefit, this thing is a known geometry. Known geometry. The geometry is known, stable, and it's almost self-equalizing kind of geometry. Whereas like even if let's say there was some deviation, there is a very good chance this can equalize itself. Basically the water pressure itself could be like, hey, you're off here, I'm gonna put some extra pressure here. It's like sphere is like, I got you, man. Equalizes. Tube or capsule design, basically how all submarines are, those require even finer tolerance. Like they really need to be precise, because there is place, the center spot is the weak spot. Here there is no weak spot. So till that point, going from basically a sphere to capsule, that itself created an issue. Now be mindful, all military submarine designers are like, yeah, we cannot go that deep, and you're going that deep with low money. That's a seriously bad thing. Now everything is focused on this carbon fiber. Now this is footage from their own website, you can see it, and this is the weak link. This is the one, this is the reason of their poof. Now why is that? Well, reality is carbon fiber is not a stable material, because it's not isosnormal material. It's not like metal crystal lattice. What it is basically threads. This carbon fiber threads, fiber thread basically, and binded with epoxy. So you have 2 materials in one material. Now you're making it like this. Now based on how you're weaving it, you're gonna have structural strength in some direction, but not in another direction. For example, James Cameron keeps saying this, and this was kind of makes sense from engineering point of view. If you have to handle pressure, basically like I build this, I have to handle pressure, carbon fiber is your guy. It's like, hey, I need to contain this pressure. Carbon fiber is like, I got this. It's like, hey bro, we are building this spacecraft, it has to be like 1 pressure and outside is 0. Carbon fiber is like, I got you, fam. Now you try this in invert. Basically, instead of building a scuba tank, you are building invert of a scuba tank. It's like, bro, inside is 1 atmosphere, outside is 600. Carbon fiber is like, bro, this is not me. Go to steel or go to titanium. This is not me. Why? Because of that structure, the fact that there is 1 fiber, how you're winding it, that defines your geometrical strength. So you could have like awesome strength, like you cannot be crushed like this. That's awesome. But here's the, how about a biscuit packet? You must have seen. That could also happen because of the weaving structure. That fundamentally makes it non-computable. At this point in time, there is no computer that can simulate it. And be mindful, it is inherently insimulator. You're talking about every fiber, how they are working, and every basically grain of epoxy. Yeah, it can't be computed. So you can, on your computer it could work, but you do in real life is like, nope. And another fact is, because of how these things are built, inherently it will have failures, inherently. So can a company build this? Absolutely. Can a company build this to go to that depth? Absolutely. Can a company build this that goes there twice? No. Meaning it can go once, you come back up, you discard the chassis, flat out. Like even the company that is inherently was contracted for this, they're like, yeah, we can build this. It's not an issue. It's just that we cannot build it in such a way where it's like it goes again and again. Because every time you go, some fiber will break. That's a known thing. You go there, it will break some fiber. Known, absolute fact. It will weaken it somewhat. How much we do not know. Like you can go once, 1% damage. Go again, no damage. Go again, no damage. Go 4th time, some damage. Go 6th time. Now you are actually inside the fire. Go 8th time, poof. That's the whole problem. Like fundamentally, fibers will break and it will become weaker and weaker and weaker and weaker. So that's why, like, fundamentally carbon fiber loves to have pressure pushing it outwards. Pressure pushing it inwards, the fibers do not like it. So inherently flat or not sustainable. That's why everybody focusing on that is like, this is not okay. Now, people made a lot of fuss about this joystick controller, which is not an issue. Why it's not an issue? Yeah, it is an issue. Why the heck they are using Logitech rather than using Xbox controller? Or again, I was doing it, I was using a proper Xbox grade controller, and I would have replaced those puppies with basically resistive joystick controllers with optical controllers, optical, I'm saying basically magneto systems. There are mods that you can do that will make it exponentially last longer. But here's the deal. This submersibles are designed in such a way that if the crew is compromised one way or the other, let's say something happened and all of them passed out, the submersible should surface automatically. That's the whole point. These are designed what we call dead man safe. So even if Cameron goes poof inside, for some reason, let's say he had a heart attack or whatever have you, the submarine will come up automatically before the oxygen runs out. So there will be weights that are pulling it down. Some systems have very amazing design where they have electromagnets that is holding it back. Why electromagnets? Well, if you have an electrical failure, what's the first thing that's going to fail? Power rails. What's the second thing that's going to fail after the power rail failure? Electromagnets. That's why everything in the submarine, if designed properly, would be fail safe, meaning oops equals you out. You out. You will not stay underground. You're like, you out. We have learned it's the hard way, quote unquote. So every submarine is designed that way. Every submersible is designed that way. So this focusing on that is waste of time. Yeah, I do hate it. It's like, dude, you are talking millions of dollars. Xbox controller. Why Xbox controller? They do have a lot of R&D actually going into making it. So come on. You know, Hall effect sensors, come on. Come on. Like, come on. So that's the problem. That's why, like, this design can go in and out hundreds of times. This design hundreds of times without any issue. Carbon fiber, you would be lucky to get 10. Be mindful, the accident happened less than 10. So that's the problem with it. Now question is, was it an oops event or malice? Now here's the deal. People did sign the wager. Everybody's like, they're rich people, they should burn. Here's the deal. Why do you hate rich people rather than becoming rich? Why you are like, I hate rich people? It's like, why? But removing that, they did sign a wager. Now, wagers are signed whenever you are doing with something experimental. For example, if you go to routine surgery, you don't have to sign a wager. Of course, you have to sign, yeah, I consent to this and all that jazz, blah, blah, blah. But when you have to do something experimental, let's say some new radiation therapy came to that is untested, they will ask a properly informed consent. You may even need a lawyer for that, all of that. That's a different thing. Here, they tricked the, basically people. It's like, yeah, this is a new design, but here's the deal. There has never been an incident in the whole submarine history where something imploded. Like, that's not heard of. Like, that's flat out shocking to everyone where it's like, dude, it imploded. Like, it has happened where it's like you ran out of oxygen, you got entangled into something else, something, this happened, this or that. That's a different thing. Your vessel imploded, that's unheard of. That's like, how is that even viable or possible? Nobody would have even, like, really? Like, you imploded. How? Did somebody fire a torpedo at you? It's like, how the heck that happened? So that waiver was signed in what we classify as good faith. Like, again, there is laws for that. Just because you sign a waiver does not mean, oh lol. It simply means if you sign a waiver, generally it's done in good faith. For example, if doctor is like, hey, I'm gonna do this kidney surgery, and you come out and you lose the leg, that's like, bro, this area, we gave you good faith consent here. My leg, where is my leg? So it's one of those things. Yes, they did sign a waiver, but it was in good faith. And that good faith was exploited. Because here's the deal. They claimed they were certified, but nobody actually, when people actually started to investigate, it's like, dude, none of the certification is true. Most of the certification is like, yeah, we had a call with them, we're gonna do certification. And yeah, they are interested in our design. That line that, yeah, they are interested in analyzing our design, studying, is like, yeah, they are interested in our design. They say our design is interesting. They, you know, they manipulated it. So flat out, they went to lie, where it's like, dude, you do not have certification. Like, no, we have certificates. Like, dude, no, you don't. To trolling. They were flat out trolling. So all the good faith was built on a lie. That's why I specified this is a malice. Now, all of this is very easy to say in hindsight, right? Something bad happened, everybody is an expert now. But here's the deal. Did people knew before it happened? This is the critical aspect. And yes, how do we know? Because their own engineer, when they were building the carbon fiber thing, they did not do what we call destructive testing. Now, if you're building a car and you're gonna do mass production on it, you're gonna build a car and you're gonna boom it. So the reason you boom it, you figure it out how exactly it gets boomed. Same done with aircraft also. Many times aircraft wing, they will be broken. Like fundamentally, physically, they will build a full-scale mock-up and they break it because they need to know how exactly it breaks. If their predicted model breaks exactly like how they think it does, that's awesome. That means they got it. If it breaks in different ways, like whoa, 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 why the heck it break it this way? You know, all that data. That's what we call destructive testing. But if you're building one of a kind, how do you test it? Well, it will never be as reliable as actually building two of them and booming one of them versus basically doing what we call, non-destructive, basically do ultrasound on it. They chipped out on that. That was a red flag, and their own engineers brought this up. It's like, dude, I will not sign on to this. And they fired that engineer and filed law cases, suits on that, like flat out. And this creates an issue. It's like you have 40 people. There should be at least 10 people that were like, bro, will not take this kind of risk. We went from 300 meters to 500 meters. That's awesome. That's GG. But going from 500 to 4.5, we really need to be, thorough about this. No. That's the dangerous part. It's like, even if your own engineer warned you flat out, it's like, bro, no. And be mindful, everyone else in the field, because this field is very niche, very small. Everybody knew about everybody else. And there is email chain from basically authorities. They're like, bro, don't go, just YOLO on this device. Because everybody has like, hey, if you are taking your life on your own hand, go YOLO. That's your life. Like how James Cameron did, or like how that some other submarine limiting factor did. That's a different thing. But when you are taking paying customer, that's a different thing. But he was like, hey, what if we F the customer and cheated the system? And because he was putting himself on the line, many people fall into sense of self, false security, so to say. So I'm gonna do this barge so I don't have to get license for the barge. I'm gonna start diving in international water so I don't have to follow international, basically national laws. All of that was like, trolling, flat out trolling, and everybody did warn them. And this line, at some point, safety is just pure waste. Like, I'm not joking. I thought this was like attributed to him rather than like him actually saying it. No, there is actual audio of him saying that to a reporter. Not joking. With full consent. It's like, yeah, I'm a reporter, I'm taking your interview. At some point, safety is just pure waste. I mean, if you just want to be safe, don't get out of bed, don't get into your car, don't do anything. At some point, you're going to take some risk, and it, really is a risk reward question. Now, his deal, that is still the same thing if with all other vessels. The two vessels that I'm talking about, from James Cameron vessel to basically limiting factor, I have linked the video down below. Now, his deal, what's the difference? There, if something bad happens, it will not be structural failure. That's the one thing they know. It could have, let's say, electrical fire happens, he got cooked inside. Structure still would survive. Something like, something hits it, let's say, undersea mine explodes. That's a different thing. That's a different can of worm. That's like, yeah, you have to take some risk. But hey, the can that you are selling to the world, that this can is completely intact, completely stressed, like even the acrylic window is not certified for the depth that you are going. That's like, you are literally on borrowed time and it just ran out. So yes, it does classify as a menace. That's the sad part of it. That's the sad part. It's like, dude, it should not have happened. So this was my presentation on basically the tragedy that has befallen us. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press this like, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.